Hi everyone, welcome back. So now I remember on the last part we talked about was kind of like the rules of matrices, the rules of determinants. Sorry, and of course there are so many different rules. It would just outshine the concept and the time limits of this video. But now we're going to progress into like a more difficult topic, really about the determinant of really any n by n matrix. Now I know this is going to look really scary. This formula is going to look pretty scary. The first time I saw it, I cried. I don't really cry that much, but I cried because it's really overwhelming. But just be patient with me and just give me some time to really, maybe give me about 2 or 3 minutes. And I'm going to try to explain it, so hopefully it doesn't look as scary. So to find so first I want to begin though with, why do we need this formula? Certainly you can just use separate formulas to find the matrix of a 3 by 3 or 4 by 4 or 5 by 5, but since they're all really different from each other and complicated they're really complicated differences between the matrices. It's really time effective and it really helps to have one general formula we can use to calculate the determinant of any n by n matrix. So let's talk about how would we go about doing that. So there is a handy dandy formula. We can actually calculate the determinant using what's called a cofactor expansion. Cofactor expansion. So basically, we can kind of expand across a row or by a column. If you expand across a row, here's what the formula will look like. The determinant of A, again, A is an n by n matrix, is A I1 Ci1 plus AI2 Ci2 plus fancy dot 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 A I N C I N. And if you want to do a cofactor expansion across a column, you can do this formula. The determinant of A is equal to, it kind of switches, A1J C1J plus A2J C2J plus dot 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 plus ANJ CNJ. What is this C, you might ask? Very good question. The C is equal to, so a Cij is equal to -1 I plus j times the determinant of Aij. Whew. Okay, that's it. Maybe take about 2 minutes to kind of pause, breathe. I know this looks really, really, really overwhelming. Let's do it step by step. Let's start with, what in the world is this I's and these J's? Good question. So for Aij, the I represents the I is the ith row. The J is the jth column. So for example, if we have, let's say we have a really quick matrix, 1 2 3 4 5 6 7 8 9. If we're looking for A1 2, this means we're looking for the element that's in the first row. First row. Good thing this isn't an English course. Second column. And this is in the first row, second column. So that is equal to, so AI2 is 2. Also, A31 is the third row, first column, that is equal to 7, and so on and so forth. But if we're going to kind of elevate what that means, so that's the lowercase aij. That means the Aij is the element in the ith row in the jth column. But if we have like a capital Aij, not G, sorry, Aij, this means this is kind of equal to the original matrix A subtracting the ith row, subtracting the jth column. Now, I don't mean that like mathematically, like taking A minus, because you may not be able, because you're not going to be able to do that because of the properties of matrices. But I kind of mean intuitively. Think about it. We're taking A, and let's say we're taking whatever matrix we're given. We're taking away the ith row, and we're taking away the jth column, and whatever's left is equal to capital Aij. It's better if we have like kind of like an example. So let's say we have capital A 2, 3, and we're going to say that this is A again. So if we're looking for capital A 2, 3, we're going to take the original matrix A, we're going to subtract, quote unquote, subtract the second column, the second row, and we're also going to take away the third column. So let's see. We're looking at the second row. I haven't used a highlighter in a long time. Second row, and we're looking at the third column. Ooh, I haven't used a highlighter in a long time. Second row, third column. So whatever is left is capital A2, 3. So this is 1, 2, 7, 8. That is what capital A2, 3 is. And so on and so forth. Now, why do we have to have this element here, -1 to the I plus j? It's kind of complicated. It kind of goes back to vector calculus. Remember, anytime we're finding like the determinant of like a matrix, there's always like this plus and this weird minus that comes out. So the C element really ensures that we really talk about whether it's going to be a plus or a minus. Since Cij is equal to -1 to the I plus j, when -1 is even, let's say when -1 is even, this is going to be +1. When -1 is odd, this is going to be -1. And again, we're going to multiply that by the determinant of this matrix. So let's see. We went over what this is. We went over what this is. Great. And we also went over what Cij is. I know it still seems really, really, really overwhelming, but I really hope that you would stay with me for like maybe one example, and I hope it really just comes together.